This is the third in a series of recordings on analyzing screening designs. So you should have watched the first two videos, and you should have read the screening design notes part 4, and you should have read the Hoos and Jones book chapters 2 and 3 before watching this video. And in this video we're going to continue our discussion of approaches to analyzing screening designs. So in previous recordings we've pointed out that generally with screening designs there are more potential effects to estimate than we have degrees of freedom to estimate them. We often say the designs are super saturated. So one of the strategies we discussed in a previous video was called forward selection, where we use a procedure where we add terms one at a time to the model, and we add those terms that give us the biggest improvement in our fitting statistic, in our case AIC or BIC, and the procedure stops when either you've saturated the model, meaning you've put in the maximum number of terms, or the addition of any further terms would not improve the fitting statistic. Well, there's another approach called all possible models, which works generally quite well with screening designs. And the basic idea of all possible models is to literally fit every possible model of every possible size up to some maximum, where the maximum depends upon the size of the experiment that you did. And generally this is an old idea, but it was previously hampered by the fact that this could be, the number of potential models could be very large. In fact, if I had, say, 15 effects overall, and I wanted to look at every possible model, that would be potentially almost 33,000 models. Well, today that would be considered a trivial computational task, and in fact we can attack problems where the number of potential models are in the millions and even billions. So we're going to look at all possible models, and we're going to apply it to the extraction experiment. And again, just as a quick reminder, one of the statistics we will use is the AIC statistic, and remember it has its companion, the BIC, that we've discussed in previous videos. Okay. So we're going to look at AIC and BIC, and for every model that's fit, we will take a look at those statistics, and we'll try to use these statistics to focus in on the models that may be the best compromise between over and under fitting. Okay. And I'm going to work through this for you, so the notes simply show you how to do it, and all possible models is located again in the stepwise platform. And it turns out, in fact, let me back up and point out something to you. Notice the denominator, okay, for the AIC, n minus p minus 2, where n is the number of runs, so it's 12 for the extraction experiment, okay, and p is a parameter that includes the estimate of experimental error. So it turns out that the biggest model you can define has to be greater than or equal to n. Another way to put it is p must be less than n minus 3. Okay. So this is a constraint on our ability to estimate the AIC. So if you take a look at the number of unique runs, it's 12. Minus 3 says that p has to be less than 9. So we're going to go ahead, and what we will do is we will go ahead and use p equals 8. That's the best we can actually do, okay, in our study. So I'm going to go ahead and actually switch over to jump. Okay, and we'll show how to do this. Okay. So let me get this out of the way, and we'll use the extraction experiment one more time. Let's see what I want to do here. So there's the extraction data. I will go to Fit Model. I will specify the largest possible model, which is again all the main effects and all two-way interactions. So I highlight my 6 effects, and under macros, factorial to degree 2. Yield is the response. Go under personalities to stepwise. And then in the stepwise report menu, click on the down arrow and select all possible models. The maximum model I can fit is 8, and the number of models to see, it's really up to you. I'm going to say 10, so for each size of model it'll show you the 10 best, or whatever the maximum happens to be. The heredity principle, when I do all possible models, I do not select it. In other words, I let the procedure just fit a lot of models, and then we'll try to sort through them. So I'm going to click on OK, and there is our output. So there are all our models, 1, 2, 3, 4, 5, 6, 7 through 8. In this table actually is important to us, but I really want to analyze these designs in terms of AIC and BIC. It's actually awkward to do it here in the actual output. So one nice thing about jump is that almost all output you look at is actually tabled. It's not flat text. So I right click and select Make into Data Table. Okay, so this is a data table that's been created. Okay, and I'm going to click on AIC, column header, right click, and sort. So I want to sort ascending because smaller is better. And I'm going to create 2 columns. Remember, in an earlier video and in the notes Screening Design 3, I mentioned I like to work with these delta values of AIC. So I'm going to create a new column. I'm going to call this one Delta AIC, and the subscript C is just a special version of it that Jump uses. Right click, go to the formula editor, and I want to take every AIC value and from it subtract the minimum for the column. So in Jump you go to the statistical functions and select column minimum AIC. Okay. So notice the smallest model is a 0, and we basically look how bigger models compare to the smallest. Similarly, I'm going to do the same for BIC, the same manner. So I go to the right click, go to the formula editor, and select BIC minus, and again under statistical functions, the column minimum for BIC. Okay. So now I have these 2 statistics, and as I said, especially in small data sets, they will rarely agree on what is the best model. So what I like to do is, and we should do more of this in analyzing any data, and what we want to do is graphically look at the delta AIC and BIC. So an easy place to do this in the graph menu is Graph Builder. Okay. So the x-axis is number, the size of the model, and then I'm going to drag over AIC and BIC. And just to make the plot easier to read, I'm going to put the cursor right on the vertical axis header, right click, and I'm going to move delta BIC to the right. Okay. So notice, again, smaller is better. So if we look at the data, AIC is indicating in the range of 4. 3, 4, in fact, I would say I'd consider models in the range of 3, 4, and 5. BIC is headed us to bigger models. This, again, in small data sets, BIC can lead you to overfit. And in fact, one of them is of interest to us in particular. We've actually seen this before. This is the minimum BIC model, and it does appear overfit. So we're going to take a look at a few models, and we're going to fit them through the original all possible models output. Okay, so at least I have some idea of what I'm looking for. So how do I select some models? Now first I have to take a look at my original all possible models output, and I'm actually going to sort that ascending by AIC. This is to make things easier for us. And I'm actually going to hide the model column. Okay, so I'm going to set this to the right. Now this is of interest to us. These are our models. Notice, looking at AIC, as I said, it's really zeroed in on 4, 3, possibly up to 5. Okay, so I take a look back at my output, and I said, well, I'd really like to sort the output or filter it so I only look at models with these smaller AIC and BIC values. And there's a nice little tool in JMP, and it's under the Rows menu. And it's called Data Filter. You can filter data based upon specified variables. So I'm going to pick delta AIC, and I'm going to click on OR because it's AIC or BIC that I'll use, and I'll pick delta BIC. Okay. So what I'm going to do, I'm going to say I want to look at all models of, let's say, AIC that are less than 4. JMP indicates there are 3 such models. And how about BIC models that are less than a similar value? Okay. So JMP indicates altogether there are 4 models that meet this criteria. Okay. So I'm going to actually examine those 4 models. In other words, these seem to form a set of best models. Okay. So notice, if you go down to the data table, look to the left in the Rows pane, and you'll see 4 are selected. Just put your cursor right on selected, right click, and select Data View. You can create a new data table, sort of a very quick filtering maneuver. Okay. So what I'm going to do is to try to keep the screen real estate as clean as possible. So these are the models that have been selected, and I'm going to go through them and select the models that I want. So I'm going to fit the 3-term AIC model. So I click on it. I'm actually going to scroll up and run that model. That opens my fit group. Okay. Go back down. The next model I'm going to fit is the 4-term model. This is actually the best model. Okay. Run that model. Okay. And then notice there's another 4-term model which looks quite good. In fact, there are a couple. But what I'm going to do, since I've already fit a 4-term model, I'm going to just go down and fit this 5-term. So remember I said I'd look at models at 3, 4, and 5. Again, in a video, I'm not going to look through all potential models. Okay. And then finally, I'm going to sort this by ascending by BIC and select the best 8-term model. So that gives me my fit group. Okay. So I'm going to close these other windows because I really don't need them. I now want to focus on my fit group. Okay. So again, in the fit group, I have a lot of windows open, reports in my fit group. So I'm going to hold the control key down and click on, it doesn't matter which report menu I use, but I want to take a look under row diagnostics, actual by predicted. I want to take a look at the residual by predicted plot. That's for looking for lack of fit. And I also want to show the press statistic. Okay. And at this point, we would simply go down through the models. By the way, if you're doing this as your own project, once you've set up your fit group, I strongly recommend you go to the fit group menu at the top, and under script, select save script to data table. You've probably put a lot of work into setting up the fit group, so you want to save the script so you can easily reproduce the fit group. So we look through the models. We've looked through some of these before. By the way, the model, one of the models that was selected, okay, this is a 4-term model, has 4 main effects in it. Actually, it looks like a reasonable fit. Okay. This is our 5-term model. This included, let's see, 5 main effects. Okay. And again, it has a reasonable press. And then once again, our 8-term model looks to be badly overfit. Okay. However, unless we have some way of verifying it, it could possibly be a good model. But we have to be very concerned about the fit. We may well be overfitting. So here's what I'm going to do. I'm going to click on the report menu, okay, for response yield. It doesn't matter which one. Again, first hold down the control key. I'm going to click on response yield, go down to save columns, and I want to save the prediction formula. Okay. Then I can close fit group because I have already saved this to the, remember I said save it, the script to data table. So at this point, I have 4 models, and when I look through them, okay, notice that the bigger model includes a number of interactions. Okay. The smaller models have really gone for main effects, and there's really no guarantee that one of these is actually overall the best model. By the way, the 8-term model would indicate that relative sparsity is not holding. So if we really think there may be a large number of potential interactions, our only choice at this point would be to augment the design, and we'll talk about that next.